All right, Harmony Science Academy College Math students. We're looking at section 3.3, okay, March 23rd. The title that you want to place in the middle of your notebooks is Rational Expressions. A is not 1, okay? I'm going to talk about what I mean by that here in a bit, okay? What I'm going to do here is give you guys some time to do a Google search for factoring a trinomial where a is not 1, okay? Kind of take some time, see what you can find, okay? There's different information on that topic. They all produce the same conclusion, so as long as you got something, we can work with that, okay? All right, so a is not 1, okay? So when we look at trinomials, okay, basically they have this form, okay? When a is 1, right, most of you guys can factor that pretty easy. All right, so let's just kind of prove it. All right, so let's say we have x squared plus 5x plus 6, x squared minus 1x, I guess minus 6. Okay. Now, when they look like this, right, when a is 1, okay, it's invisible, but nonetheless, when it's 1, you guys are pretty awesome at factoring that really fast, right? So if let's set it up this way, right? So the two numbers that multiply to give me a 6 and add to give me a 5. Okay. And here we have, they multiply to give me negative 6. So I'm going to go with negative 3. Okay. And I'll check this one. Negative 6, add them, negative 1. Okay, so I'm good. Okay. And then you guys are awesome at what? Canceling like terms. Okay. This one has a plus, that one a minus. So we'd be left with x plus 3 over x minus 3. Okay. This is what we call simplifying a rational expression. Okay. Now, again, this is review. This is not the new lesson. We're going to focus on when a is not 1. Some of you guys already have that skill. We're going to look at it anyways for everybody else. Now, the other thing that you're going to be asked for is excluded values. Okay. So what you guys should have already been taught, okay, is that you can have an expression, almost any expression in the numerator, okay, basically or virtually any expression in the numerator, but the denominator cannot be 0. Okay, this is undefined. Okay, so you should have been taught that, you should have learned that, and it just has to be in your brain at all times. There's no exception, regardless of where you are, in what math class, in what campus, what school. You can never divide by 0. Okay, so, and I have a there. Hopefully it's not misleading anybody. Let me see here. Well, we'll easily just call it x, okay, or n. Doesn't matter. Okay, just any number, any type of expression in general, okay, divided by 0 is undefined. So you guys have seen that in the calculator, right? 3 divided by 0 undefined. So you guys can kind of toy with those values. So the same applies here, okay? Pay attention. So when you guys see x's and r's and k's, we're using, in this case, okay, let me go blue here, x, okay, and don't freak out here. X is a variable, which means it has different values, okay? And where do we get those values from? It's all the numbers that are possible, okay? This is all the real numbers. So we can be plugging in all sorts of x values. But when you combine the fact that you can never divide by 0, we have to ask ourselves, hey, when will this ever equal 0? Because if it does, It's undefined, and we can't allow x to be those values. Okay, so therefore what we need to do is we need to investigate, hey, where does this bottom, okay, equal 0? What values of x makes this bottom a 0? Okay, then we have to throw them out of there. Okay, so in general, x can be any number in the world unless it causes us to divide by 0, then we have to worry about it. So those are the excluded values. So what do? You take the bottom and you set it equal to 0. Okay, this is for the excluded values. Okay, that's it. Hey, what x's are going to make this equal to 0? So we really can't do much with it until we factor it. So then we factor it. Okay, so if this is 0, 0 times whatever's in here will equal 0. And if this is 0 times whatever's in here will equal 0. So then x minus 3, I got to ask, when does that equal 0? Okay? And x plus 2, when does that equal 0? Okay? And that's where you guys perform that very basic math. You add 3 to both sides and you get x equals 3 and x equals negative 2. So if I put in 3 in here, right, let's do it real fast. 3 squared is 9, minus 3 is 6, and 6 minus 6 is 0. So when x is 3, this is 0, right? So we need to what? Because it's undefined, we need to throw it out, okay? Same thing here, okay? Check this out, negative 2. Negative 2 squared is 4, okay? If I plug it in here, it's plus 2, okay? So now I have 4 plus 2 is 6, minus 6 is 0. So if I plug this in here, I get 0, and I'm dividing by 0. So I have to throw that out. So when we talk about excluded values, okay, we're saying that yes, x, okay, this means x is an element of all real numbers. So yes, x can be, okay, all real numbers, okay, but we're going to exclude x cannot equal negative 2 and 3. Okay, this is hopefully making more sense. It's like, oh yeah, that's right, x could be any numbers, but if these special numbers will cause a 0, which would mean we divide by 0, so we have to exclude them out of this set. So x can be all of them except these two. Okay, all right, so now let's go ahead and talk about the problems you guys are going to be looking at. And again, our main focus is, where is a not equal to 1? Okay, sometimes it will, perfect. We're going to try and focus here. So you guys know how to simplify. You guys know how to find excluded values. The only thing is, what about when a is not 1? Now, some of you guys have your own techniques, which is cool, but I want you guys to follow this, at least for your notebooks and for whatever material we work on, okay? So let's go ahead and try this process. Now, again, I don't have to do the whole thing because you guys will perform. What I'm trying to do is find opportunities where a doesn't equal 1, and how do we factor that out, okay? So let's start off with this little chunk up here, okay? Again, I'm not necessarily doing the whole problem. I'm just focusing on factoring, because once you guys can factor, you guys know how to do everything else. Simplify and then get excluded values. So let's look at this top part, okay? Now this top part, you guys have seen it before. Okay, I'm gonna use the space over here. Now we need it for us to factor this trinomial. It's got to have x squared as the highest exponent. X, let's see here. Right, let me put it here, I guess in red. It's an invisible 1, and this one technically has an x to the 0. Anything to the 0 is a 1, so we can leave those invisible, okay? All right, so if I'm looking at this one, I can't have a cube, so I'm going to factor out 1r, and I'm left with 3r squared minus r minus 30. Okay, now why is this one worth us doing together? Because a, okay, up here in the front is not a 1, so now I have to factor that. Okay, So r is going to stay there, but my only focus is this guy right here. Okay. So let's go ahead and do that. So then this method that we're going to use here in class, okay, it's called a slide and divide. Maybe some of you guys found that through your Google search, and here's pretty much how this works. Okay. Go back here. Okay. All right. So what the trick suggests is for you guys to rewrite it in this way: r squared minus r, and take this a and what is over here, this c, and multiply them. Okay. So now if you look at the way it's written, okay, at least temporarily a is 1, so you guys can factor it the way you guys have known to factor it. Okay, so let's do that here real quick. And we've got r, okay, two numbers to multiply here, and that add up to this, so we're going to go with -10 and 9. Okay. All right. So the next thing we've got to go ahead and do is basically divide by this coefficient of 3. Okay. So let me put that in a different color. Whoops. Okay. Now let's go ahead and approach this side. The fact that 10 can divide it perfectly by 3, okay, is going to force us to bring this 3 up here to the front and write it as such. This 9 divided by 3 does reduce, so we're going to be left with r plus 3. Okay, and that's it. So of course I'm forgetting this r, so I can bring it up here, but this top portion, the numerator of this rational expression, has been factored. Okay, so we can do a quick check this time, and the other ones you guys can check them yourselves, but we've got 3r times r, which gives us 3r squared. This times this is 9r, with this is -10r, so we're left with -1r, and this times this gives us the -30. Okay, so again, this method works. There's a rationale behind it, but that's beyond the course. If you guys are curious, we can kind of play with that. Okay, but right now you want to really pick up on this slide and divide. Okay, so again, we've just factored that out. That's what you want up here on top. That's what we've done. Okay, so I'm going to go ahead and clear this. And let me see if this one, let's see what happens with this one. Okay, this one, you guys would factor out typically a 15r. And you're left with r squared plus 4r plus 3. Okay, now the fact that this is a 1, you guys can go ahead and do that yourselves. I don't need to cover it here. Okay, but it did look interesting at first, right? Because it looked like we might not have a equal 1, but after you factor out the greatest common factor, you do have a 1. So now you guys can continue there yourselves. Okay, so let's see what else we can fish around here. Let's go ahead and try the top of this one. Okay, so again, I'm not doing the whole thing. You guys can do it. All we're doing is, hey, what about some of these tougher looking ones? Okay, all right, so this one's kind of written backwards. So let's go ahead and write it in in proper form. Okay, so I'm going to take out an x, and I'm left with -7. Okay, and while we're at it, in this case, just to make my life simpler, I'm going to take out a -x here. Okay, so let me start over here. So if I take out a -x, I'll be left with 7x squared. And again, if I take out a -x from here, I'm left with -16x. If I take out a -x from here, I'm left with -15. Okay? All right, so my only focus is, can I factor this on top, right? So let's go ahead and now see if we can apply that slide and divide trick, okay? So let's not make sure that we don't forget this negative x at the end, but right now my focus is in here. So, whoops, if you caught that, good. If you didn't, it's an x cubed, we just took out one x, okay? All right, so we're gonna go ahead and just, we can pause the video here and you can look at the last example, okay? And we basically just wrote it like this: x squared minus 16x, and then we'd have to multiply these two, which is what? Negative 105. Okay, so what did I do here? I took basically a times c, okay, and I've got this new expression just like this, okay? Again, where the whole purpose of this trick is so we can get rid of a temporarily and we can factor it the way we have, okay? So this is a pretty awesome trick, especially as you guys get faster, okay? So now we need to come up with two values that multiply to give us 105 and give us negative, they give us negative 105 and add up to give us negative 16. Okay, and depending on your comfort level, some of you guys are faster than others, but we can go ahead and have this, okay? This times this is this, and this plus this is this, okay? So now, what is it that I do here, okay? The next thing that I do is we can pause the video and you can respond. But if you said divide by this 7, you are correct. Okay, so let me go blue here. Okay, now here we do have 21, negative 21 divided by 7 works out perfectly, so we're gonna reduce it as such. Okay, and here the 5 divided by 7 doesn't simplify perfectly, so we're gonna go ahead and squeeze the 7 up in the front, plus 5, okay? Again, since some of you guys probably got it, some of you guys are iffy, let's go ahead and check this one real quick. This times this gives me 7x squared. This and this is 5x. This and this is negative 21, so we get this. And this times this gives us that, okay? All right, so hopefully you guys have caught on to it. I think we can go ahead and squeeze in one more here. It's been already kind of a long video, so let's see what pops up. Okay, I think that's gonna go ahead and be good enough. Okay, if something pops up, we'll go ahead and address it in class. Guys, appreciate your time.